Hi class, this is Ms. Cook. Today we're going to talk about the law of cosines. This is going to give us another way to solve oblique or non-right triangles given the case that we can't use the law of sines. So the law of cosines is presented here. So essentially if you have A, B, and C, capital A, B, and C are the angles of a triangle, and then little a, B, and C are the opposite sides of those angles, then we have these relationships here. Notice how these relationships are all in terms of one of the sides of my triangle. So for instance, a squared equals b squared plus c squared minus 2 times b times c times cosine a. Okay? It looks a little daunting, but it's pretty straightforward. And we're going to use the law of cosines in the next example here in order to solve a side angle side triangle. Alright, so here I have a sassy triangle, side angle side. So with a side angle side triangle, I am given an angle that's essentially nested in between two other sides. So what that means is I don't have an angle and an opposite side in order to use the law of cosines, or the law of sines rather, and I don't have two angles in order to find the third angle. So I'm sort of going to have to use now the law of cosines. So since I am given angle A as 60 degrees, side B as 20 units, and side C as 30 units, I'm going to use the law of cosines to first find side A. So we're going to find side A. So it's side little a. So that relationship said that a squared equals the sum of the squares of the two other sides, and then minus 2 times b times c times cosine of a, angle A. So now that I have that, all I have to do is fill in all my information here. So b is 20, so 20 squared, plus c, which is 30, so c squared is 30 squared, and then times 2, minus 2 times b, which is 20, and then times c, which is 30, and then cosine a, which is 60 degrees. All right, and then I plug that in my calculator, and I get, all right, and I get that a squared equals 700. So then I have to square root both sides, and that gives me that a is approximately 26.5. I'm going to use one decimal place. Pearson will tell you how many decimal places to use. All right. So now that I have all my sides, you can use the law of sines, or you can continue with the law of cosines. I and your book recommend using the law of cosines. The law of sines will sometimes give you two solutions that you'll have to check, unfortunately, so that gets a little more tedious. But we can creatively rearrange the law of cosines to find my other angles. All right, so notice that I'm missing angle B and angle C. So let's put that we have 26.5 for side A. I just need angle B and angle C. So let's use the law of cosines to find angle B. All right, so we have a similar relationship for side B. So B squared equals the sum of the square of the two opposite sides, so that is a squared plus c squared minus 2 times a times c times cosine of angle B. All right, so what we can do is rearrange this a little bit to solve for cosine B. All right, so that gives me cosine B, that gives me 2ac cosine B equals a squared plus c squared minus b squared. I simply move the term 2ac cosine B over to the left-hand side of my equation, and then b squared moved to the right-hand side of the equation. So now I want just cosine b, so I'm going to divide both sides by 2ac. And then cosine b equals a squared plus c squared minus b squared. I'm going to use parentheses here, and then divide by 2 times a times c. So that gives me a really nice, easy formula to use to find cosine of b. All right, so now what I need to do is fill in everything. I'm going to draw a line and continue my work over here. So cosine of b, we're still trying to find that, but that equals a squared, which we found in the previous problem was 700, plus c squared, which is 30 squared. I don't know what 30 squared is, so I'm just going to leave it like that. And then minus b squared, which is 20 squared. And then divided by 2 times a, which is the square root of 700. I'm going to leave it like that just so we're not rounding too much for each answer. Okay. And then c, which is 30. All right, so then that means cosine b, I put that in my calculator, so I get that cosine of b is 0.75592, and I get a bunch of decimals. Okay, so now what we have to do is use an inverse trig function in order to find what angle b would be. All right, so I'm going to use cosine inverse of 0.75592 is going to give me angle B. Okay? So I'm going to show you guys a quick trick in your calculator. So I want to use this whole decimal here to plug into my cosine inverse function. So I'm going to hit second cosine and then second answer, and that's going to plug in this whole decimal. That's why, again, I'm not rounding too much for the final answer. All right, so I get that angle B is 40.89. I'm going to round that to approximately 40.9. And I'm going to assume degrees. All right, so now we just need to find, sorry, let me record my answer there. So now we just need to find angle C. Well, to do that, since we have our two angles, we can just say angle C is 180 minus the other two angles. So minus 60 and minus 40.9 degrees. Okay. And I get that angle C is 71 or 79.1. And my triangle is complete. All right, we all have a wonderful day.